Here we will check how our ANSYS results compare to the hand calculations. First, let's take a look at the reaction in the axial direction and compare it to our estimate from the hand calcs. So the reaction is at the frictionless support at the top, so I'll just drag that to solution and say evaluate all results. And that gives me the reaction, and if I look at the results, the reaction in the X and Y directions are very small, and the reaction in the Z direction is around minus 684 pounds. And that, so we know, we are expecting that the reaction is in the negative Z direction, so the sign matches, and the magnitude is around 720 pound force from the hand calc, so that matches reasonably well. So that increases our confidence in our results. Then we had the hoop stress, and at the exit we are expecting the value around 1700 psi. So if I go here, and the hoop stress is basically so if I go to the bottom, okay, it's the stress out of the plane, which is the X direction. So I can say, so I highlight solution and say stress normal in the X direction, and say evaluate all results. Okay, so that'll give me the stress out of the symmetry planes, which is very close to it, and which is basically that direction because we're cutting it like that. If I go in and probe, so what I'll do is I'll probe the values, and I need to move this a little bit to the right so that it's away from the color bar for the probe to work. And if I probe it there, you see it's very close to our estimate. So that's an additional confidence builder that our results, match reasonably well with the hand calcs. And the third hand calc that we had looked at was looking at the expansion due to the thermal strain. And if I go to the total deformation at the end of the third time step, it's of the order of 1 inch, and so that, and that's at the bottom. So this is giving me an estimate of how much the bottom has expanded relative to the top due to the thermal load. And you'll see that if you compare the deformation at t equal to 2 and t equal to 3, you'll see that most of that deformation, almost all of it, is from the thermal expansion. And you can compare that to alpha delta TL. So if I annotate that, so this should be of the order of alpha delta T. So you can use alpha for the nozzle times the change in temperature, 630 degrees Fahrenheit, times the length being the axial extent of our model. And you can confirm that, this value is close to that. One could also do a check on the bolt pretension, which we won't do here in the interest of time. So the hand calculations give us quite a bit of confidence that our results are reasonable.